Welcome to the Occupational Safety Leadership Podcast, episode number 208 with Bruce Main. In today's episode, we'll sit down and talk a lot about prevention through design. I think it's a really good program that's out there. I really wish more people would sit down and embrace this and do a lot of the upfront planning as opposed to just hurrying up and getting started and kind of doing some outside the box thinking. But before we really get into it, Bruce, could you tell the audience a little bit about your background, and then we'll talk about a couple of examples out there.
Sure, David. I'm a mechanical engineer. Got degrees from MIT and the University of Michigan. I'm been focused on safety for now close to 30 years plus maybe. And I got interested in the concepts of prevention through design in my prior employer, who did an awful lot of litigation cases. So it
Ah,
was involving where people got hurt and there was product liability lawsuits. And the facility, the company was they were experts in warnings and instructions. And so I spent a lot of time reconstructing accidents. And after about 2 or 3 years of that, I got interested in how do you prevent these circumstances, because I never saw a situation where an engineer identified a hazard and said, who cares?
right,
Always,
right.
it was always some unexpected or unanticipated use or circumstance. And that led me to do my master's thesis on what do engineers know and do about safety, which took me to some pretty interesting places in risk assessment.
Oh, very good. It's really interesting that you brought up that you would go back and almost like construct a accident again. I know that I've gone back and I've looked at a lot of accidents, but I never kind of thought about let's kind of set up the conditions exactly that same way and go through it. That's a really good point.
And it was actually a lot of fun. It was like detective work in many ways.
Hmm.
One
Hmm.
circumstance where the allegation was that some lighter fluid used for charcoal lighting, that there was something wrong with the warning label about how the lighter fluid should be used. And through testing, we were able to demonstrate that the the cause of the incident was that the charcoal had been initially lit and then it didn't light fast enough for the person. So they sprayed
Uh,
some more on there and we got a big cloud. And more now, we're seeing, particularly with industrial incidents, there's video footage of what occurred.
mhm.
So in our litigation work now, it's less about, well, what happened and more about why.
Right, right, right.
And so I mean, it's kind of a sad day to sit down and know that you're going to watch a video clip of somebody getting hurt or killed. But it certainly strikes the point home about the importance of doing prevention through design.
Right, 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 right. And you also brought up that you guys were making the different products and all that stuff. It's probably really hard to envision every way a person would use a product because we like to think that everybody is coming to the same is coming to the table, not wanting to get hurt. But then when you think about it, much like that person, they got it started and then, well, wasn't fast enough. I just need to spray on some more, pour on some more. And those are things that you would hope somebody wouldn't do. It's really hard to prevent those things.
Right. And I agree, you can't prevent everything, but
Mhm.
with the risk assessment methodologies we have now, we can certainly anticipate the reasonably foreseeable tasks that people are trying to do and help them through the design make the safest way to do the job the easiest and the most effective. Because our safety research shows that when the safety systems don't impede that work, don't get in the way, they stay in place. But when you add safety onto a machine or a product after it's been largely designed and developed, it gets in the way, it slows people down, and they end up bypassing or taking those systems off.
Right, 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 right. Well, I really liked when I first had started to look at this whole system, probably 2005 or so. maybe my dates are going to be a little bit off, but I really liked how they had a couple of examples about how people, instead of getting on a roof to finish a roof, they would literally almost like make a roof on the ground and then take a crane, I assume, and lift it up right into place. So you still had exposure, but you had a whole lot less exposure.
Right. Right. So that there you're identifying the tasks you've got to put a roof on. The hazards are certainly are falling. The solution there is to do it at ground level as much of the work as you can. And then, you're still going to have to get up on the roof at some point. But if you've got the shingles on there or whatever roofing you have, the fall hazard is much less.
Oh, yes, yes, yes. And you think about all the different like mechanical things that, well, I should say human activities that happen off also. So one of the things that I did when I was just a very young bald-faced boy was to do those roofing jobs. So and as being the young guy, I had to carry the tar paper up and down the ladder and the shingles and all that kind of stuff. And I always thought there's got to be a better way. But I was so young and stupid, and everybody was just hurry up, move faster, that you didn't really have much time to think in that kind of environment because it was just so. Um, Now, of course, we're talking about the 70s and 80s, not that safety was not important then, but you kind of had a little bit of a macho type culture still in the construction field. So,
Sure.
yeah.
Sure.
Yeah. Could you go over a couple of the other examples that you've seen in your day about how people did really good projects nowadays?
Well, I would say when you look at machinery design, this is something we do every week, every day almost. When we're doing risk assessments or talking with manufacturers, you identify, okay, what does somebody need to do? What's the task they have to perform? And then you can identify the hazards associated with the tasks. And then look at risk reduction measures that are going to be effective and prevent people from getting hurt. The trifecta is when the safest way, the easiest way is the most productive way. And we get that very frequently. The bad ones are when you've got to add a safety device or a light curtain that really wasn't designed from the get-go, so it makes the job difficult or impossible to do, and then you get situations with bypassing. And going back to, you can't prevent everything. There's different views on what is considered reasonably foreseeable misuse. I
Hmm.
had a project recently where somebody was concerned about somebody crawling on a conveyor that was going to a robotic palletizer. And of course, you had to have an opening large enough for the carton to go through. So
Hmm.
the product has to get through, but the opening's large enough that somebody could climb through there. And we got into an issue of a discussion about whole body access, and that's the term of art now,
Hmm.
and what's reasonably foreseeable. And just because somebody could go through that hole, is it something that you have to prevent? And when you get into the prevention through design, examples of, well, if you have, if there is no way to get in there to do the job, say the robot has a case that's not quite lined up and you have to make an adjustment. If you don't allow for somebody to get in there, then somebody's going to go through the hole. You know what's
Right,
going to happen. If, however, you provide an interlocked access door at the right locations that make it easy to stop the system, you go in, you make the change, you get out, you reset it and start, chances are they're going to use that because they don't really want to get hurt.
right.
In that case, when we put some constraints in the new ISO standard that's being developed about when is whole body access a consideration and when is it not.
Hmm. Right. I haven't done much with the ISO type standards, but I've done a lot of semi S2s and that stuff, and it was always really good. What I always liked in that industry was that the vendors, they never wanted anybody to get hurt. So before we bought something, I could always call and say, "Hey, I want to get the following things like documents, the schematics." Everybody sent everything right over to me. It was a really good thing to sit down and at least say, even though that we're not like physically there and we're running it, are we doing everything we can to buy something safe? Right from the get-go, are we already looking at the interlocks? Can you give us a sample of a lockout, tag out? And it doesn't mean it 100% works for us, but it's a fantastic starting point that we can say, we're going to go back and look at the different energies, and here's my isolation point at all these spots. So
That's
that's
great.
been a really big help.
Great. That's great, David, because I mean, I've had the opportunity to work across several different industries, and just like you described, everything you just said
Mhm.
applies to other industries. It's just the tasks and the hazards are different. The semiconductor industry's got some really unique composites and chemicals and hazards associated with that. But when you're talking about robotics or steel making or pharmaceutical or food or packaging, similar kinds of things. You need to be able to do the task and you need to provide a way to do it safely.
Right. I've only run into a issue one time where a person said, "Well, I'm not sure I want to send you everything because you haven't bought my thing yet, and I'm purposely using like general terms, of course, you haven't bought my thing, so I don't want to send everything to you." And it's really easy to go back and say, but this is part of the buying process, of the procurement process, is we want to understand things, not look at the cost only and not worry about it. And then we'll worry about how safe it is after it shows up. You know, you brought up a very good point that it's really hard to put something on afterwards because if it wasn't designed that way, most of the time folks are going to do everything they can to not use it because they just don't understand why it's there too.
And that's the heart of prevention through design. If you're still working on a CAD model, you can make changes every day and it doesn't cost anything. And if you wait until, okay, we're going to do a risk assessment at the end of the development process when the machine's getting ready to ship, it's just not going to be very effective.
Right. And I think that we as a society do a better job of looking at risk also. Whereas before we were very focused on OSHA, and of course that's awesome, and that's great. But the standards haven't always kept up with today's society. Then. So we have to look at the other industries out there, not industries, the other standards bodies, if I'm saying that right, and see what they can do to help us out to make things safer.
I agree. I mean, one of the things that I do as part of my job is I help write industry standards
Mhm.
and both at the national and international level. And as a standards writer, one of the messages that we hear loud and clear is get common. We don't want to have standards for Europe that are different than Asia, that are different from US, and people have to build equipment and machinery differently. So there's a lot of effort trying to make things harmonized and consistent,
Mhm.
which is great for everybody. Everybody
Mhm.
wants for that.
Yeah, yeah. So the one thing that I've seen is that a lot of people will send you the whip for the tool, and then it's up to you to figure out what plug that you're going to put on there. Because you always have to say, hey, here's my voltage, here's my plus or minus, here's how clean my power is. And those are things that I never thought of as a safety guy, but somebody has to put that plug on. Somebody has to say, hey, I'm running the power from point A to point B. Do I have enough power? Is there going to be a panel and my electrical, my disconnects and all that stuff too? Um,
And I would generalize that, David, to, the integration of equipment and machinery and systems. Okay. It is the way it is from the manufacturer, but there's only so much they can do.
right.
Once it gets to your facility, you or somebody you hire has to integrate it into your system. And that's also part of prevention through design and the risk assessment process to look at, okay, what are the tasks the integrator has to do? And what do they need to be, what information do they need so that we can make certain that your voltages and your connections are the right ones when they get to the facility, and it's just a matter of making the connection as opposed to trying to scramble and jury rig something.
Right. Um, the one thing that we've done, and we've learned a couple of lessons the hard way, is we sit down and literally say, you must build it to this spec then, as opposed to something that's really very general out there, because then that helps us to understand, of course, what we're getting and have it pre-set up as much as we can because when it comes in, the whole thing is about getting it in service, and then we have to build something because at some point in time we're going to stop building that. So we have to have it installed fast too. So Yeah, yeah. And we've done a pretty good job, I think, also of standardizing when we look on the back, if we're going to run like nitrogen and CDA and water and all that kind of stuff, then like exactly what the back is going to look like, because you always have to have a way to basically to plug into those things at the end. So that
And
really helps out.
the more we can anticipate and prevent that up front, prevent problems up front, the better off we are in all respects. And certainly when you get into more detailed CAD models and able to look at some of these connections and how somebody's going to get in to do a task, we are doing more and more risk assessments on CAD models before the equipment is built and able to look at, okay, what's somebody going to need to do and how are they going to do it?
Right, right, right. Well, I think that you brought up a very good point that CAD is virtually free. It does take time, of course, but for the most part, you can really do a lot of the getting rid of hazards up front, right, right in there then. So, um, let's talk about residual hazards. I know it's hard that different companies have a different, we'll call it in air quotes, a risk appetite about what they think is going to be acceptable and what is not acceptable. What are some of the different risk appetites that you found out there?
Oh, it depends on the industry. If you're
Mhm,
working in pharmaceutical, their appetite for residual risk is very small.
mhm.
If you're looking at construction, for example, there's a lot more because it changes so much. And I do think overall we're seeing improvements in safety over time, but it is true that different organizations have different levels of acceptable risk, and they always will.
Yeah, 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 yeah. Well, I think that it also depends upon. Actually, I don't want to go forward with that thought, I think, in hindsight. So, so let's get back to the construction use for prevention through design then. Have you seen anything on like the trenching and shoring side then as opposed to the roofing?
Well, the requirement to use the trench, losing the
Trench
word,
box.
boxes. Yes, thank you.
Yeah, yeah, yeah.
Using trench boxes is a great way to prevent um, the subjective. Is this okay? Is the slope okay? Is the soil that we're working in sufficient to prevent the cave-ins? So that, I mean, I know it's a pain to have to put them in. It takes some time, but it does certainly elevate the level of safety and allows workers to work more quickly without having to look over their shoulder about the stability of the soil next to them.
Oh yes, 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 yes. I bet you that there's probably a lot of really good examples where people are using not like a what's it called again? Like a soft dig system and running pipes and just kind of doing things where people are not exposed to these things too, you know.
Sure.
Yeah.
You used to have to dig a trench and put pipes in now, and now we can tunnel in and not have anybody in there at all.
Yeah. Wow. It's really coming a long way for that stuff then. Yeah,
I mean,
that's great.
David, one of the areas that I'm seeing great promise is with prevention through design is the alternative methods to lockout.
Ah,
So
okay.
in ANSI Z 244.1, which is the industry standard for control of hazardous energy, we now allow the use of alternative methods in lieu of lockout.
Hmm.
So whereas before you would have to always isolate the power, lock it out, try out, and then go do the work, there are lots of examples where people are using properly designed alternative methods to enable access to machinery to fix an upset situation, clear a jam, um, lubricate, um, do setup, do changeovers that under the OSHA requirements from 1989, you have to do lockout, but you can do these safely using the alternative method if you do it right.
Hmm.
When you design that into the system, you're preventing, well, you're preventing a lot of bad stuff and offering a lot of good stuff in terms of keeping people safe.
Hmm. I have that on my list of things to do in this year is to really sit down, dive in, and look at that stuff. Then, so are they allowing things like interlocks to be used?
That's
Or I
one of
should
the
say,
devices. That's one of the devices, certainly. And interlocks, area scanners, light curtains, depending on how trapped keys is another um, that that controls the energy and prevents things from moving, prevents things from starting, but it doesn't isolate it. And if you think back 35 years ago to 1989, technology wasn't as reliable as it is today, that in many cases, relying on a control circuit or type device really wasn't allowed. Um, Now, the reliability of these systems is such that it's really a design change, and I would consider it more of a prevention through design approach
mhm.
to, and there's a lots of applications where lockout's just not feasible. It takes too long. You can't lock out a blow molding machine because you're gonna, if you lock out the heater, you're gonna end up with a big mess. So, yeah, right? So now you're
Right.
creating bigger problems. And there's all kinds of other examples where if we can control the energy and keep people from getting hurt while doing the task, it's actually a better solution than locking out.
Right, right, right. And it helps folks because all of us are flawed. And if you're issued that one lock, that one key, do you have it on you? Is it back in your toolbox? Is it back in your locker? And just any time that we can make things easier for folks that are going to do a better job out there. So yeah, I
It's
have
a
I have
great
to sit
example
down
of
and read that.
great example of better and safer. I mean, I've talked with one manufacturer, a supervisor. He said, and this is a situation where they've got large equipment, multiple energy sources, and in order to actually do a changeover, they have to lock it out, make some adjustments, power it back up, move it, lock it
Oh,
back down again. And they may have to do that 2 or 3 or 4 times before they're ready to run again. And he said 85% of their lockout tagout violations are people just making mistakes. They forget an energy source, they forget a tryout step. They're not trying to cheat the system, they're not trying to get hurt. They just made a mistake. And with alternative methods and prevention through design, we're actually making it not error-proof necessarily, but certainly less susceptible to mistakes.
right, 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 right. So how do they view using a emo for killing the power?
Well, if it's done properly, it really comes down to the analysis, and that's what's in the Z244 standard.
Uh-huh, uh-huh.
It tells you because there's lots of different ways to go about this, and you got to do the homework. And homework's not
Right.
hard, but you got to do the homework because what we don't want is somebody relying on an e-stop as a safety circuit if it's not sufficiently reliable.
Oh, gotcha, gotcha.
So you might hit
Okay.
the e-stop, and if the contact blocks drop off the back, you wouldn't know it, and the
Mm-hmm,
machine could start up and take your arm off, or worse.
mm-hmm.
If you go through the homework and do the analysis, you're going to be able to say, yes, we've got the right system in place, we've got the procedures in place, we've done the risk assessment to support this, and we can go down this path.
Wow. That sounds really incredibly easy. I probably need to bump up my timeline a couple of months and really sit down and do this. Just because not that lockout tagout is hard, but like all things, you can make it really super handy. And so this one has a different kind of lever. Now I have to go get the only one that fits this, but it's in a different spot, and just those types of activities.
Right.
Wow, that is really good, really
David, I can share
good.
with you that OSHA's taken a look at their requirements under 1910-147.
Mhm.
And they are in the process of updating those. And I can't say with certainty when they're going to come out, but it's likely very soon. And when they do, I fully expect they're going to allow the use of alternative methods under certain circumstances.
Wow, that would be great then. That would probably help out a lot of folks because they might think they're doing it right and maybe they're not doing it right. But if you had your interlock, your emo, whatever that device was, that would be awesome and great. So, Bruce, it looks like we're bumping up on time. Could you take a couple seconds and let folks know how they can catch up with you and just really I hate to say pick your brain, but pick your brain on these kinds of activities because we have a lot of things to talk about, and I think I wandered and I think I need to have you back for a part two and a part three to really dive into a couple things.
Sure. I mean, if you go to our website, designsafe.com, that's DESIGNSAFE.com. We've got a lot of material up there that helps talk about some of these topics. You can get my contact information from that site. It's Bruce at designsafe.com is my email. It's probably the best way to get in touch with me for this.
hmm Awesome, Bruce. Thank you so much. And with that, episode number 208 is complete. I want to thank everybody for joining me today. My name is Dr. David Ayers. Thank you and have a safe day.